Okay, we're going to work on counting the number of atoms in a molecule. This is one of your worksheets, and you're going to be given a molecule and learn how to first identify which elements are in a molecule, and then count those elements, and then total them. This stuff is pretty easy. It just takes a little bit of practice and knowledge of some of the vocab. Now, the first vocab term to look at is something called a subscript. This is on your Quizlet. Subscript is the small number telling you how many of each atom there are. For example, if you look at H2O, water, you'll see that H has a subscript of 2, and that tells you that there's 2 H's, or 2 hydrogens, and you'll also see that the O has no subscript, and that would mean it has 1. So we don't write the 1 in there, but if there's no subscript, that just means there's 1. So really, H2O is the same as H2O1. Now, if you look at the coefficient, that's the next vocab term, and that is the large number in front of a molecule that tells you how many of that molecule there are. So for example here, you see that there's a 3 H2O. That means that there's 3 H2Os. Now in the above example, where there is no coefficient, that would be 1. So there's 1 H2O. So the coefficient tells you how many molecules there are. If you had a great amount of water, you could say, let's just say, for example, 1 million H2O. That would be a pretty big amount of water compared to 1 molecule of H2O. Okay, so let's practice some of these. If you look down here, first example is CaCO3. Now, for the first thing we do is we notice that there's 3 different elements. There's a Ca, okay, there's a C, and an O, which is listed for you here. Now you're going to count them, and the first thing you notice is that you look at the subscripts, and for Ca there isn't a subscript, so that would mean that there is 1 Ca. Now if you look at C, there's also not a subscript written, so that would be a 1. We don't say Ca1, C1, O3, but when you don't see a subscript, that means there's a 1, and now there is a subscript for the O, and there would be a 3. Now there's no element 4 in this substance, there's only 3 elements, and for the total you just add them up. So take out your calculator or your fingers and go 1 plus 1 plus 3, total is 5. So number 1 is a pretty basic type of problem, and you'll do some practice with these. If you look at number 2, 3, 4, they're all really the same type, where you just add up the elements. Now if you get down to number 7 is a little bit more complex. It's not hard, it's just there's another step to it. Now for this, you'll see that there's a coefficient of 2 in front of the molecule. So there's 2 SiO2s. What that means is everything after the 2 gets multiplied by 2. Some kids like to put parentheses in there. You don't have to, but some kids find it easy to put parentheses there. So what that means is you take, for Si, you notice there's a coefficient of 1. So you go 2 times 1, coefficient times a subscript, and that means that there's 2 SIs. Now for O, you'll see that there's a coefficient of 2 in front, and then you times it by the subscript, which for O is 2. 2 times 2 gives you 4. Now you learned this in math as the distributive property, so everything after the coefficient gets distributed, so everything gets multiplied by 2. So 2 times Si, 2 times O, 2. And now if you add them up for the total, 4 plus 2 gives you 6. Okay, so there's a couple more types of those problems. If you look at 8 and 9, those are some of the same types. Now for number 10, it gets a little bit more complex. Again, it's not difficult, but more complex. Now first of all, for this, you have to identify that there is a Ba, there's also an O element, and there's also the element of hydrogen. Now there is no 4th element. Now to figure out the numbers here, we'll start with Ba. For Ba, there's a subscript of 1 and a coefficient of 2. So 2 times 1 gives you 2. There's 2 bariums. Now for oxygen, you have to start with the subscript that's outside the parentheses. You have to distribute that. So there would be 2 times 1 to start with. 2 times 1 gives you 2 oxygens, but then you also have to times that by the coefficient in the front. So basically it goes 2 times 1 times 2, that's the coefficient, okay, for a total of 4. So there's 4 oxygens. 4 oxygens. Now for H, same type of thing. You have to start with the parentheses, and you go 1 times 2 to give you 2, times the coefficient in the very front of the whole molecule. 2 times 2 gives you 4. Now if you add them up, you get 10. So 11, 12, and 13, they're just a little bit more complex because you have to start with the parentheses and then at the end multiply everything by the coefficient. So I would say the first 9 are pretty basic, easier ones. Okay, then 10, 11, 12, 13 a little more challenging. So see how I do with these, and then we'll go over these at the direct station. Good job.